All right, so on this worksheet, the first thing that I think threw people off was y-axis up. This is just the same idea though as x-axis right and left. We're not going to do the problem any differently, okay? So in order to do part A, we want the particle moving up. We want to know where is the velocity positive, okay? So they give us velocity, and then here's the next hurdle, trig, everybody's favorite. All right, so we had to look at this and we had to say, okay, well, I don't need to take derivative yet. I am going to have to do that in part B, but I just want to know where is this velocity positive. So I need to figure out where is this velocity equal to 0 and do a sign chart. Okay, so I want to know where is t times cosine t equal to 0. So that means that t equals 0. And then we got to figure out, okay, well, where does cosine t equal 0? All right, this goes back to trig. Right up here, we got 0, 1. Right down here, we got 0, -1. Cosine's the first number. So cosine equals 0 when t equals pi over 4 and 3 pi over 4. I don't know why I'm saying that. I've been doing I'm like on autopilot. What should I be saying?
Pi over 2.
Yeah. Pi over 2 and 3 pi over 2. Long day. All right, so here are my numbers that I'm going to put on my sign chart. Okay, and 0, I already knew that was going to happen, so I'm going to draw my sign chart like this. I'm going to start with 0, I'm going to end with 5, and then pi over 2 and 3 pi over 2 are going to be in here. All right, now we're going to test. Down here, I'm going to test it into velocity. Let me change colors here. Velocity. And then that's going to tell me something about the position, which is a y. So take something between 0 and pi over 2. So pi over 6. So pi over 6 is positive, and cosine of pi over 6 is positive. So because velocity is positive in that interval, the y value is going up. You could have also drawn a little arrow like that. That would have been fine. Now, because I got plus first, what do you think I'm going to get next? She's not here. A minus. All right, how could you check that? What's a value you could pick?
Pi.
Pi. Cosine of pi is -1. So minus, you could say down, or you could draw the arrow down, and likewise, you're going to get this on the last one. So there was a little bit of trig in here, but it's the same kind of concept we've been doing. So where is this particle moving up? Where velocity is positive. So that would be 0 to pi over 2. Union that with 3 pi over 2 to 5. That's the answer. Okay, before we move on to part B, I want to show you guys how your calculator could help you in this problem. And you can use your calculator in this stuff. On the quiz, it'll be all calculator. As we proceed, we'll get to where, you know, I'll be more specific about which ones you can and can't use, but a calculator on. But for right now, we've already done this without, now let's do it with. All right, so if we graph velocity, I think some of you may find this to be a little bit easier. So if we go to Diamond F1 and clear out what we have here, and watch how I'm going to type this in here. I'm going to do x times cosine x. I can't do implied times. Your calculator will spit that back at you. You have to do x. You can't use t here. You have to use x. So x times cosine x. If you don't put the times sign, it's going to tell you something about implied times. It's going to give you an error. Okay, now I'm going to set my window. Okay, my x min and my x max, they told me what to use, 0 to 5. So I'm going to do 0 and 5. My y min is -10 and my y max is 10. That's fine. It may turn out I need to change it, but For now, I'll just kind of leave it at the standard 10 to 10. But I want everybody to notice I did 0 to 5 because that's what the problem told me. Just do the t values from 0 to 5. And then we're going to do graph, which is diamond F3. Okay, so I can kind of see what's going on here. If I wanted to scrunch my window down a little bit more, I could. But really, I just need to know where is this velocity positive. So I can see that it is positive from 0 to some number right here. And so we haven't done this specific part in a while. If you hit F5, if you select 0, choice 2, and it says lower bound, so go to the left until you're to the left of that 0, press enter, and then it's going to say upper bound, so go to the right, and then you press enter, and so that's the 0. Okay, anybody want to guess what this is exactly? Pi over 2.
If we use that way on the quiz.
If you were accurate to 3 decimal places, you're good.
Okay.
If it's multiple choice, you just have to match up which one is correct.
Wait, did you push?
So let's try it again for this one. So F5, pick choice 2, 0. And I'm trying to find this 0. I'm already to the left of it, so I can already go ahead and press enter all the way over there. Now I got to go all the way to the right. So lower and upper bound just means to the left and to the right of that particular 0 or x-intercept.
You just push regular F5?
Mm-hmm. And so then you get this, which is the same as 3 pi over 2.
Oh. And then you push value or 0?
0.
Oh.
Okay, so that's a totally different way of thinking about this problem. It makes it into a graph problem, and it uses the calculator to help you. Okay, you may like that, you may not like it. Either way, we saw it. Okay, writing expression for acceleration. So can you guys tell me, what do we know about how do we get from velocity to acceleration? We take the derivative. Now if we're going to do this by hand, we have to use product rule. Derivative of t, that's a 1, times just regular old cosine of t, plus. And then you switch which one you take derivative of. So now I get to just write regular t, and I take derivative of cosine t, which is negative sine t. That's it. That's your answer. While we have the calculators out, can anybody remind me of how your calculator how you can find the derivative in your calculator? Like in the home screen. Okay, so in the home screen, remember F2 and F3, that's where all the good stuff is. If you hit F3, see that D for differentiate, select that. So F3, 1. And then I'm going to type in T. Real quick, I'm going to clear my variables. I'm going to make sure that I don't have anything stored in. You may want to do that. T times cosine T. Here you could use X or T. And then since I am using T, I'm going to do comma T. Yeah, you can use any letter here. And Y equals, though, you can only use X. Okay, so that's the same thing that I got when I did this by hand. It's just a little simplified, and we can kind of see how that would happen. The minus would be made to a negative. And so that's where the calculator could be helpful. I'm going to do a lot of calculator work today because I feel like we need the practice. Okay, here's 2. So 2, very similar situation. Particle moving along the y-axis, a velocity, we have some more trig. So let's try to do this first, see how much we can do without the calculator. In which direction, up or down, is the particle moving at time t equals 1.5? So they're actually telling us the time. We're not finding the time. They're telling us the time. And that is velocity. So all we got to do is plug in 1.5 in for t. All right, you cannot evaluate this without a calculator, but you actually can determine whether this thing is positive or negative. What is 1.5 as a fraction? 3/2. You square it, you get
9/4.
9/4, which is 2 1/4. 2 1/4 radians. Okay? So up here we have half of a pi, which is about 1.5. Over here we have pi, which is about 3. So where does 2 1/4 lie? Right in here. So that's quadrant 2. And in quadrant 2, sign is positive. So this whole thing is positive. We can do that part without a calculator. Obviously much easier to do with a calculator. Okay, so which direction? Moving up, because v of t is 0, or I should say v of 1.5 is 0.
It's positive.
Yeah, long day, sorry. I'm just going to keep saying that all lesson. Just kidding. Okay, with a calculator, just as a reminder, you would just need to, type in. When you have a number in front, by the way, you don't have to hit the times sign. You could do times, but you don't have to. And so this would be sine and then 1.5 squared. Now, since you typed in a decimal, if you're in auto mode, it'll give you a decimal, which is what you want because it makes it easy to tell if the answer's positive or negative. So that's a positive velocity, so the particle is moving up. Okay, part B, find the acceleration at time t equals 1.5. So first we just need to find just what acceleration is. So again, by hand would be product rule. Derivative of t is 1 times sine of t squared plus just regular old t. And now when you take derivative of sine of t squared, you got to take derivative of the sine part, leave the t squared alone, and then go times the derivative of the inside. M&Ms, exactly. And then plug in 1.5. Now you definitely need a calculator to do this.
It doesn't open up quiz.
No. I'm quick with the nose today. Okay, so you type that in. And I'm not going to model that for you, but you get negative 2.049. And because acceleration is negative, what does that tell us about? Is velocity increasing? Velocity is decreasing because, and you can say A of, or you could say V prime of 1.5 is less than 0. You could have said A of 1.5. Is less than 0. Okay, last part. Yeah.
Can you still use this thingy?
Yes,
Okay.
the little chart. Yes.
Yeah, and still just plug
Yeah.
position.
Because position is f, velocity is f prime, and acceleration is f double prime. So everything we learned in chapter 3 applies. All right, so let's look at the last one. This is what we did yesterday. We talked about speeding up and slowing down. Now here we have a positive velocity and a negative acceleration. So is that representing speeding up or slowing down? Why? The signs are opposite. So here's how we can say that. Slowing down because v of 1.5 and a of 1.5 have opposite signs. What if they were both negative? What would the answer be then? Speeding up. Okay, so before we move on to the next page, you guys all tried this on your own. I want you to assess, like, if you did try it. I want you to assess, why were you stuck? What was the hard part for you? Was it the trig? Was it because you are not comfortable with the calculator? Was it because you just thought it was harder than what it really was? Was it because you don't understand some of the concepts? And then we just got to figure out how to improve. All right, so on the next page, we have this. Anybody want to give a guess?
E.
E?
It's either E or C.
It is either C or E. I'll put that out. So I'm hearing some C's and some E's. Okay, so real quick, the first thing we need to really establish is that this is velocity and all of these are position. You cannot just match the table to the picture, to the graph. If you did, you would have thought the answer was B. Like B, this graph matches the table the best. Okay, how are velocity and position related though? Velocity is the what of position? The derivative. Now when we're looking at graphs, what do we look at to determine derivative?
The slope.
The slope. So I'm going to think about slope. In other words, at t equals 0, I don't know what the position should be on my graph, but I know the slope should be -1. So if we look at choice A, at 0, this graph starts off increasing. That slope is not negative anything. Okay, so it's not A. What else is it not just based off of that? B and D. So that's how you narrow it down to C and E, one way. Okay, and they kind of have similar shapes, and it's hard to see if you're just looking at the board, but on your paper, there is a little dip down right here, so it does decrease and then increase. All right, so then we look at 1, 2. Okay, at t equals 1, the slope should be 2. So look at our two answer choices that are left. Here and here. One of these has a slope of 2, and one of these does not. And you may not know which one has a slope of 2, but one of these has a more obvious slope. One of these has a slope of 0. Which one has a slope of 0 at t equals 1? At t equals 1. A slope. On E, right here at t equals 1, the slope is 0, which means the velocity is 0. So it's not E. So C seemed kind of weird, but we got rid of all the other ones, so it has to be C. Okay. All right, next page. Okay, let's first make sure we understand what we're given and what we're being asked to do. X of t, and they tell you in the graph, this is the graph of position, which is weird. We're not normally given that graph. Normally given the graph of velocity. Okay, they give us some information, but I'm going to get straight down to it. For what values of t is the velocity of the particle increasing? Anybody want to take a guess? I got a B. I got an A.
I think it's B.
So we all think it's either A or B? Or we're like, I don't know. Okay, so here's one thing I'm going to mention. Where is this graph increasing? From 1 to 5. This graph is increasing. Position is increasing from 1 to 5.
It's A.
But that is not what they're asking us to find. Yeah. So B is not it. B is like the trying to get you. It's the gotcha answer.
It's A because it's concave up.
Yeah, how did you guys get to concave up?
With the chart.
Yeah.
So basically, if this is like F, and this is saying F prime is increasing, that means that F double prime, which would be acceleration, by the way, is positive. That would be concave up. Or like the chart, I'm just kind of talking it out for everybody to understand. So that's why the answer is A, concave up.
So which one is going to be like?
Quiz is more like what we had been already practicing in class a couple of days with some of this thrown in there.
This is harder.
But this, like every problem I put on this worksheet, they all have a twist. And I wanted you guys to try them on your own before we went over them. All right, number 5. Okay.
I have a question.
Sure.
Sorry. It's where it says for what values is the velocity increasing?
Mhm.
So why are you looking at double prime?
Because its velocity is increasing, so velocity's derivative basically the second derivative then,
Yeah.
that has to be positive. I mean, here's the thing. I'm given something, and I'm told its rate of change is changing. Like, it's because we start with position. If we had started with velocity, this would have been, that's where most people kind of read this problem. This is the graph of position. And when they say velocity is increasing, what they're saying is acceleration is positive. Yeah.
Okay.
It's like the rate of change of the rate of change.
Okay.
Yeah. Okay, so on number 5, we're given velocity equation, and it says how many times does the particle change direction?
Can you just look at the x to 3 and take one away?
Well, that could give you a possible answer. So the question was, can I look at that this is the 4th and say, if I set this thing equal to 0, like, could I get 4 zeros and therefore 3 times it changes direction, or what, or something like that, okay? So that could be, but we know that sometimes it doesn't work out that way. And this is not factorable, like, so we can't factor it. So we need to be sure, all right? So we can either set this thing equal to 0 and do a sign chart, okay? Or I'm going to challenge us to do this with the calculator. Okay, so if you go, because if we solve the graph, we could know right away if something weird was happening, which, by the way, there is. So let's take that out. And when I go to my window, I want to be restricted to only see what they want me to see. So what should my x min and x max be on this problem? Yeah, -3 to 3. No, not that one. Back that up. -3 to 3. And again, the y's, I just need it to be standard. I can always change that if I need to. So once you have that, go ahead and graph. So I can't see the bottom here, but I'm not really that concerned about it. This is the graph of velocity. So velocity is positive, then negative. So here's an answer right here. And they don't really want us to find these, although we could. They just want to know how many. So we have one answer so far. Okay. What's happening here? Velocity is negative. It's 0 and then negative again. Is velocity changing signs? Or is the particle changing directions here? Nope. But it is here. So we have 1, 2 answers. You get to use the calculator on the quiz, but I really don't think there's anything where you have to use it like that, like something like this. So the answer is 2. There are only 2. There could have been more than 2, but there are only 2. Yeah.
Can you just take that and plug it into your calculator equal to 0 and see how many answers you get?
But that's still only going to tell you how many times v of t equals 0. Like if you actually did a sign chart here, what would happen is you get 3 answers, and then I believe it looks like this. You get some back-to-backs.
Oh, okay.
Okay, and we cannot tell by looking at this unless we were to factor it, which we can't factor it, and like who wants to do that anyway? And so there are still only 2 answers, even if we had done this with this as a sign chart. You go to window. So see how window is above F2 and it's the same color as the diamond. So diamond F2.
So we're just looking at when it changes from negative to positive.
When the velocity changes signs. Either positive to negative or negative to positive. That's when the particle is changing directions. Basically what this weird little thing right in here is the particle is, in this case, x-axis. So the particle's moving left, it stops, but it doesn't turn around. It keeps going left, but it does stop for just a split second.
Oh, that's like a second.
Yeah, if we were to graph something, it would look like a saddle point.
Because you don't do just the x-intercepts because that would be talking about position.
It's kind of like when we were doing, we did critical numbers, and not every critical number was a relative max or min, or not every PPOI was a point of inflection. Okay. It's the same reasoning.
Okay.
Okay, I am not actually going to do 6. I'm going to give you the answer, though, as B, and I'm going to let you try to do that one on your own. You just need to take the derivative. We don't know how to derive this by hand, so please use the calculator to do that derivative. All right. Turn now in your packet back to this page. I think it's page 10. Yeah. We're just going to do just a little bit of review. Some of the problems we didn't get to yesterday. This is just good review anyway. Okay, so remember that sometimes all you're given is a graph. And usually when you're given a graph, it's of velocity. But you need to read the problem and make sure that it is. And in this case, it is. It tells you and it's labeled right there. But be real clear, this is the graph of velocity. If you try to do the problems thinking this is the graph of position, every answer is going to be wrong. So this is you want to slow down and make sure you understand, like, what are they giving you? So at what time is the speed of the particle the greatest? I want you to see if you can come up with an answer and write it down.
So it says x of t is position.
X of t would be position. As would y of t. Speed is just, like, since we're given velocity, speed, all you need to know is speed is the absolute value of velocity. Because we don't need to look at the derivative to do that, since we're given the velocity. You could do it by looking at the signs, but let me ask you is this, when is velocity the greatest?
Furthest from the,
So the answer to this question is at t equals 8. There's no units, so I won't write them. Because at t equals 8, what's the velocity? -6. The velocity is -6, but the speed is just 6. Okay? The velocity is actually greatest at t equals 12. That's the highest point on the graph. You'll see the difference between those two questions. You don't really have to get into anything else. This is not asking about speeding up or slowing down. That's number 4. We'll get to that. Okay, what about 2? At which of the times 2, 6, or 9 is the acceleration the greatest? Now what are we looking at on the graph? The slope. So which one? You can kind of, if you put the points in, I think it makes it a little bit easier. At t equals 9. It has the steep. It's not even just that it's the steepest, it has the biggest slope, because you do have to pay attention to sign here. Like if this segment in the middle had been steeper, that would have been a problem, because that's still a negative acceleration, so we couldn't have listed that as my answer. Okay, what about 3? Over what time interval is the particle moving to the left? What are you looking for on the graph? where v is negative. That's going to even be our justification because v of t is less than 0. So what is that interval? 4 to 10. Okay, I want you to try to do 4 on your own. Okay, so when speed is decreasing, what are the two scenarios that could happen? So let's say if velocity is positive, then what's acceleration? Negative, and then vice versa. So when we go to the picture, what we're looking for, and I'll just change colors here, if velocity is positive and decreasing, or velocity is negative and increasing. Those are the two sections where we'd be slowing down, the particles slowing down. And the other ones would be speeding up. So we'll list that out as 2 to 4 and 8 to 10. And we got to make sure we write a justification. So we'd say because v of t, and you could say v prime of t or a of t, have opposite signs. I don't know what I'm doing. No, I do need a nap.
At first in my head, I thought like it auto-corrected to that. I was like, wait, no, you're writing this right
My
now.
brain is auto-correcting. Okay. Turn the page. One last problem for today. Okay, we already did that example 2 at the end of class yesterday. So then we get to this table. Okay, let's just do this together. Is there a time when the particle is at rest? Ding, ding, ding. Is there a time? We're going to use a theorem to explain our answer. And the answer is probably yes. So what do you guys think? What does at rest mean? Velocity is equal to 0. I don't see a 0 in the velocity row.
But it's between.
But it is between, ding, ding, ding. That's your hint as to which theorem we're using. We know that 0 is between 3 and negative 1. Okay? That means that there must be a time. Which theorem is this? Intermediate value theorem. So let's list out the condition. V of t is continuous on 0 to 10. I'm writing way too big. I'm probably going to run out of room. So we need to write something about 0 being between here. Now, if you put the 3 first, make sure you put a greater than 0. Don't put 3 less than 0. You could have switched this whole thing around and put negative 1 first. Negative 1 less than 0 less than 3. As long as it's accurate, you're good. Okay, so in place of 3, that was v of 2. In place of negative 1, that's v of 6. So by intermediate value theorem, v of t equals 0 on 2 to 6. Okay, last question. Is the speed increasing or decreasing at t equals 2? And then we'll do it for t equals 10. So looking at t equals 2, I only need to look at these two numbers. Velocity is positive 3, acceleration is negative 1. So at t equals 2, speed is decreasing. It doesn't ask us to explain, but what would be our answer?
Because V of T and A.
V and A have opposite signs. Okay, what about at t equals 10? Increasing. I see some negatives, but that's okay because they're both negative. Velocity is negative and acceleration is negative. That's that whole speeding up in the opposite direction. Okay, so speed would be increasing. That's